other major companies. And also joining us is Bernard Guy from the Victoria University of Wellington. He's a real master and veteran of the industry, from starting out with regular engineering to industrial design, going into robotics, and even medical stimulation. So a real expert on the PolyJet J750 types of printers, and I look forward to hearing from them both.
Yeah, so we might as well introduce them to them. So might as well show them on the screen here. So hello, everyone. So Alicia, I guess we'll start with you. I guess a little short introduction. I know Anthony already gave like a little small gist, but you know, a little something about yourself and why you're having an amazing talk with us today.
Of course. Yeah. So my name's Alicia. I am an industrial designer and UX designer at Priority Designs. And so I'm just really excited to kind of share some of the really cool, vast range of projects that we get to work on and how we incorporate design realism into those. But yeah, really excited to just share, and as someone who's really kind of starting out in the industry, have that perspective for, you know, other students or people who are really new, hopefully making design realism a little bit more attainable.
Awesome, awesome. Thank you. Bernard, you're next, sir.
Hi, everyone. Hi from the bottom of the world in some ways. It's been an incredibly strange world. So I'm coming to you from New Zealand. At our little bubble down here, and it's summertime, and we're doing pretty good. So I hope everyone else is doing pretty good. It's a very odd year. Yeah, I'm going to really just do the stuff about education, really, and how I just groove on the machine at the Stratasys PolyJet in the way that I suppose we're trying to inspire the youth of today to think about making in whole new ways. So yeah, I'll be coming to you about that.
Awesome. So, Anthony, I guess you can just take us away into our first presentation.
And by take it away, I will just hand over the virtual mic over to you, Alicia.
Awesome. Sounds great. Let me see if I can get this to share. Hold on one second. Google Meets is a little new for me.
It's all good.
All right. Can you guys see my screen?
Mm-hmm. Yep.
Amazing. That's great. Okay, awesome. Well, thank you guys so much for having me. I'm excited to share and hopefully start a good conversation around design realism. I was able to catch a little bit of that last webinar, and so hopefully this will continue to be engaging and people will learn something new. So to start, I just want to reintroduce myself and give you guys a little bit of context for my background. So I'm Alicia Kozlowski, and of course, as I said, an industrial and UX designer at a design firm called Priority Designs. I have a background, of course, in industrial design from the University of Cincinnati, where I will be finishing my degree this spring. And over the years, I've had the chance to work with and intern at a variety of different companies and organizations. I've worked with small design research and ethnography organizations, designed jewelry at Fossil, worked on the Alienware team at Dell in Austin, and even spent some time living abroad in Madrid, working for a small software startup and doing UX design and research. But all of that has brought me back to Priority Designs, which combines my love for a bunch of different fields in design and puts them all under one roof. And so as I share today, I'm going to be talking about design realism and what that looks like for a firm like Priority and how it fits into our process. So Priority Designs is a research and product development company located in Columbus, Ohio, and it's about 30 years old. So I often refer to it as a kind of traditional, quote unquote, industrial design consultancy, where, you know, we work with clients to design whatever it is they need. It's honestly one of the best environments to work and design in. Everyone is incredible at what they do and just incredible people, which really makes working on all of these different projects a great time. And so not only do we have design, but we have a top-of-the-art prototyping lab, incredible research team, and lots of talented engineers. Sorry, not designers. They also sometimes design, though, all under one roof. And so, of course, during COVID, it looks like under many roofs, but it's a pretty collaborative environment overall. And so we've worked with clients in a bunch of different industries, from medical to sporting goods to homewares and everywhere in between. You may recognize some of the names of some of our past clients. And of course, this is just a segment of the incredible projects that we've gotten the opportunity to work on over the years. And so, as you can see, our designers need to be able to adapt pretty quickly, because you never know what's coming in the door, but there's always an opportunity to learn and grow and stretch yourself, which is really awesome. So that's a little bit about me and where I work. So today I want to share about two main topics as it relates to design realism. First, just briefly touching on what it is, why it's important, and how to get there. While I'm sure some of you are already experts, the GrabCAD community always blows me away. I want to make sure to touch on this for those who are still learning and trying to get more into design in the industry. And then we'll get to look at how it fits into the design process at PD, and I'll get to share about a recent project that we've been working on and how some new innovations that are happening in the 3D CAD world are making design realism and realistic prototypes even easier to achieve. So with that, what even is design realism? And I think the fact of the matter is it can mean a lot of different things at different stages in the design process. And so you can explore design realism in sketch concepts and making sure that you're accurately conveying and representing your concept in the right perspective with appropriate line weight. It could look like a detailed sketch like this, or in thumbnails and napkin sketches. You can think about design realism as it relates to concept development and comparison. So looking at how concepts compare to one another and their environment or a given user. You can think about it as it relates to Photoshop or Procreate renderings, considering lighting and being able to add an element of realism to the different colors, materials, and finishes, or CMF, to be able to convey an idea. There's design realism incorporated into KeyShot renderings and photorealistic design renderings, you know, when you have to consider the overall context and even be closer to replicating realistic materials and details to make something feel more real. And there's even design realism in interface design and UI as you look into skeuomorphism and flat design techniques and how to represent physical objects within an interface. So all that to say, there's a lot of ways this can be taken and explored, and how it can relate to design and creation. But to keep us a little bit more focused, I specifically want to look at photorealistic renderings of products and how we can incorporate design realism into these types of renderings. So these are some renderings from a mouthguard project we had the ability to work on with Mogo. And you can see how there's a lot of dynamic things that you can do with a rendering that maybe wouldn't communicate as well just as a photograph. But they still take a lot of inspiration from product photography and kind of bring that together. And so really just wanting to dive into what makes this engaging and realistic and how we use images like this in the design process. So thinking about achieving design realism and how to get there, so much is in the details. I think this lacrosse head rendering is a really good example of how little subtleties really become greater than the sum of their parts. One of the first things that really brings this concept to life and gives it that element of realism is the details that you would see on an actual lacrosse head. So even considering all of the holes for threading the head, and while considering details may seem like a totally obvious thing to consider when trying to improve the realism in a design, often, especially in university and when you're starting out, and I know this from personal experience, those subtleties and nuances and details can sometimes go overlooked and can be a barrier between why your concept doesn't quite seem as realistic as products that exist like it. Something else here I want to highlight is even considering things like surface finish can really help add an element of realism in these renderings. You can see some of the noise and texture that was added to the plastic to give it that extra character and realistically depict what this could look like coming out of a mold. And so I do want to stop really briefly and just mention that a lot of what I'm going to be talking about is relating specifically to KeyShot rendering and rendering through that platform. And so there's a lot of really great resources to learn more about that, and then also a bunch of different software that you can use, but we specifically kind of focus on KeyShot. But yeah, so back to the rendering. So while all of these details help to make this rendering more realistic, you do have to make sure that you have the right foundation set. And so here you can see the drawing that actually inspired that model that was used in the last rendering. And what I really want to highlight and note here is that even from concept ideation and refinement, key details were still considered, like material breaks, required threading holes, and even still some of that surface texture. And so while all of the details definitely elevate photorealistic renderings, incorporating that same thought into sketching really sets apart how realistic they can be. And if you're not sure how to render a specific material, I usually recommend using KeyShot, and they have all these preloaded materials that you can practice how light hits different forms and hits the shape to better be able to render those. And the last thing on just setting a strong foundation is, of course, having an accurate 3D model. While KeyShot and other rendering softwares are incredibly powerful, they can't fix a bad model. There are plenty of things you can do to enhance and even change geometry within KeyShot, but making sure that the bones and structure of your model incorporate a lot of those details that you want to highlight is really important. And that definitely gets easier when you have an accurate and realistic sketch to translate into 3D. So as long as you make sure that that foundation is set, then you get to explore those different details and textures that you see on objects in real life that really bring realism into those renderings. So, of course, outside of understanding how to create concepts and renderings that are realistic, seeing how it fits into the design process really gives us the why behind why it's important. So at priority, having photorealistic renders and being able to depict the minutia of a final design is really important, not only in the middle of our process, but as a way to showcase the work we've done in a dynamic and engaging way. Especially too during COVID, when being able to work with clients in person and see and touch products, it's a lot harder. So renderings really are relied on to help communicate. And so we'll touch on some of these in a little bit, but you can really see the range of what these renderings can show. The renderings can highlight and communicate so many different features of a concept, like surface detailing or how it fits into a family of form, the functionality, or even how it goes together in the components and overall construction. So they're extremely useful for us, especially as it relates to realistically communicating design intent throughout the process. So as we think about that process, one of the main things we see design realism affecting is how we make decisions internally as a team. By incorporating those realistic elements into our sketches and concepts, we're better able to refine them and understand which ideas are the strongest. So a big part of PD's process is using tight Photoshop renderings like that lacrosse head to communicate design ideas. And so the quicker we can get to that level, the better. There's often not too much room spent discussing or critiquing thumbnails. And so rather than having a fuzzy idea of what a designer's concepts are, we're better able to compare them because they more realistically represent what we're trying to go for. And of course, we do have to adapt, and every project is a little different. And so to give you an example of this, This is a project that we worked on, and I'll kind of come back to this project a couple times in this presentation, but we actually partnered with Stratasys to design a Bluetooth speaker that we could then prototype on one of their 3D printers, the J55. And while we did end up with a final design, the project itself was more focused on understanding how having new prototyping capabilities could affect the design process. So here,
may have had a little bit of a technical difficulty there.
Some look a lot more finished, while others are kind of more initial thoughts. And this was due to kind of having a couple of different brainstorm sessions and every designer having a different style to communicate their ideas. And so where normally thumbnails tended to be a little more finished, there was a bit more flexibility to explore. And even in all of these different ideas, though, you can see some of those same elements that help make each concept a little more realistic and easier to decipher. We had a lot of exploration on handles and clips on how to tag something to a bag. We wanted to explore moving parts and different things that could articulate to help the speaker stand or support it. And I think one of the coolest things about this project was we just had a lot of different forms to explore. The range that you see here is kind of crazy and not typical of most in industry projects. There's a lot of restrictions that are normally placed on. So this was really cool to be able to explore and have such a wide range and such an open-ended prompt. But ultimately, after all this exploration, we were still actually really captivated by this pill shape, which is kind of ironic because it is one of the most thumbnail sketches on this page, but we really loved the idea and the concept of it. And so we decided that this was the direction, and then we needed to kind of give it that dose of realism to see where it could go. And so here you can kind of see the before and after. It's almost like you ran this through a realism machine, and this is what popped out on the other side. I think it's really cool to see these side by side because it really highlights the importance of adding realistic details and how it really brings an idea to life. And so just looking at the sketch on the left, you can generally understand how it works. And the idea behind the concept. There are two halves that articulate and have this simple, consistent pill shape. You could even see some of the materiality that we were exploring. But when you compare it to looking at the sketch on the right, you can really see just how much nuance you're actually missing. You'll notice the speaker itself is just much more realistic and feasible. We added a screen, and you can understand how we would explore different textures on the surface and different color combinations. The form itself was also refined to prevent it from rolling all over the place. And the edges changed from kind of really round, bubbly fillets to more of a clean chamfer. And what I really love is just the fact that both of these sketches are stylized and important in the process, but just very different. And by adding that extra step and those extra thinking through the details and the form, you can have a much more engaging idea. And because we had such a strong idea of how this would realistically look from this sketch, it really freed us up to do a ton of really fun exploration. So we talked before how design realism in sketches helps make internal design decisions about concept and form, but here we moved back into rendering, and by exploring different materials and using rendering software like KeyShot to add an element of realism, we were better able to make decisions regarding the overall CMF of the speaker. And you can see we explored transparency, like in that initial sketch, but also so many different natural materials like cork or wood, as well as playing with different textures and surface finishes that we could use in KeyShot just to really explore that whole gamut of what this could be. And that really helped us make those decisions internally and then kind of narrow back down. And so being able to explore all of these and see those different concepts realistically rendered on the speaker rather than just being swatches or kind of small images, it really helps internally as we refine these ideas. And so the other thing that incorporating design realism and realistic renderings, I guess, to communicate an idea does is it makes it much more accessible for clients to make design decisions. So often you're not working with designers as clients, and so being able to communicate your concepts in a way that's explicit and represents reality is a really important part of the process. And so here I wanted to show a side-by-side from a project we worked on for a safety harness. On the left, you can see two examples of renderings that we use to communicate with the client. And on the right is a photo from the prototype that we created in our soft goods lab. And while ideally we would be able to show every concept fully prototyped, it's not entirely feasible to go through that kind of prototyping on concepts that might not be the right direction for a client. And so these prototypes tend to be the last step in the process for us. But on the left, these renders we're able to show earlier in the process and use them for the client to be able to have the ability to make decisions and choose which direction best suited their needs before getting into prototyping. And of course, this only works if the renderings are realistic enough for them to make an educated decision, and if they incorporate those details and realism from manufacturing to help really communicate that. And so, yeah, I just love seeing the side-by-sides like this because you can really see how all of these details come to life. And if a client really isn't used to visualizing from just sketches, renderings with appropriate detail can really allow them to feel invested in the process and make decisions, make the best decisions for product development. So another big way we use realistic renderings is to help get client buy-in and support by helping them understand the greater context of how a product will fit into its intended environment. So at PD, not only are we creating really engaging renderings to showcase a product's design and features, but often by going that step further and putting it into the environment and adding context, it really just allows us to showcase to clients something that looks incredibly real and helps inspire their imagination. And so you can see how context can look really different depending on the product you're showcasing. But I'm defining context as anything that helps contextualize your product or a feature or capability of it for a consumer. And so on the top right, you can see a dial that we designed for an assistive fitness device. And while there's no environmental context, since it's just shown kind of on a gray wall, the hand helps you understand how someone can interact with it, especially someone with limited mobility. The other three images kind of show various levels of adding context and how they can each communicate something different. So this project down here for planters we worked on for Scott's Miracle-Gro, they feel like they're in your home, but by keeping them kind of as the focus and separate, it really helps them feel like special pieces of furniture or something that you'd really want to showcase and highlight. Whereas the images on the left, they kind of show how seamlessly a product can fit into its intended environment and show that it's the right fit and that it's kind of the right direction, as opposed to it's this great standalone kind of one-off product. And that's done in different ways. In some of these cases, we've used photo backdrops with the planter or kind of in the back of this factory here. And in other cases, we really love to be able to incorporate props actually from GrabCAD and different models that can really make a rendering look realistic. It's a really great resource if you're trying to add that context, but maybe can't spend all day modeling every little thing in an environment. And so jumping into context a little bit more, on these next two slides, I just wanted to showcase how adding context really just brings a design to life and how that can really engage with clients and help with buy-in on concepts or ideas. And so this is a project that we worked on for kind of a nurse cart. And on the left, you can see how you understand how the nurse cart works, and you can understand how it looks or feels. But when you see it on the right with someone next to it interacting with it, you realize how much more engaging and realistic it feels to look at a design in that context. Not that the view on the left is bad, and we often use product shots like this to help communicate ideas, but it's really interesting seeing how just changing little things like the angle of the view and adding context like our nurse helps bring this to life. And so this is a little bit different of a comparison because rather than 2 renderings, you're using Photoshop sketches on the left, but I still think it helps communicate just subtle differences that make the rendering so much more engaging. It's so much easier to get buy-in from a client when they're looking at something that realistically represents what it could look like. And so thinking about subtleties like frosted plastic and figuring out, the buttons and a screen, is it a membrane screen? Is it LED? How does that work? What does that look like? And being able to depict it helps bring this to life. And even the subtle, actually not subtle, adding all of this water pouring in there just makes it feel like it's active and someone is using it, and just really adds a dynamic aspect to it. And of course, the sketches on the left do that just in a very different way. And so they're using the different angles and views to help stay more dynamic, and they are still really informative. But you can just see the distinction and how, at least for me, on the left, it's really engaging and a great concept. On the right, I just want to pick this up and interact with it and see it in my hands. And it's those feelings that you really want to bring out in clients to help them stay engaged and excited about the process overall. And so the last thing that I want to talk about and how those realistic renderings are used in the process is about creating accurate models. A lot of the rendering examples I've shown throughout this presentation have also been made into lookalike models to validate the design concepts. And so I just wanted to look at how those realistic drawings or even KeyShot renderings help aid us in the prototyping process and what that looks like. So at PD, we do have an in-house prototyping lab and team who use state-of-the-art machinery, some of which I've never heard of before, to just create absolutely anything that we can imagine. Pretty frequently, clients will request having prototypes made so that we can fully test the validity of concept ideas. So our designers really often work with our prototyping team to make sure that we're on the same page. And while I will say, having a realistic rendering is a huge help. Our prototyping teams are kind of wizards who can make something incredible even out of concepts with a little less information. But with that said, building models of concepts is such an important part of the product development process that being able to have those renderings to inform what that should look like can really help streamline and just make sure that everyone is on the same page and has the same expectation for end results. And so to show you an example of what this has looked like in the past for us, these are some images from a project we did with Melnor. And the bottom image here and on the right were models that are made in our prototyping lab, which help showcase the materials and nozzles of up here in the top left, which is a Photoshop rendering. And so you can just see the translation between the two of them. And I think it's incredible as someone who's still seeing things as they're created in the process. It's so amazing to see something realistically depicted, but then existing and being able to keep that line consistent is really awesome. But that is a bit of a tangent. Really just being able to incorporate realistic elements into renderings helps us not only visualize earlier how product would look when it's real, but it also helps us in the prototyping process to make sure we're all on the same page. Which then brings us back to the project I touched on a little earlier. This Bluetooth speaker is kind of that final design direction we chose for our project with Stratasys. And so we chose this after doing a lot of CMF exploration and refining some of the design and interactions a little bit. But the really cool thing about this project is we weren't just tasked with designing a speaker, but incorporating new technology to completely change how we prototype and test these models. And so to explain exactly what we did, I want to touch on how this model was created in KeyShot. And so after you import the basic model from SolidWorks, most of the design in CMF was done using KeyShot materials and maps. And so on this model specifically, almost everything on here is actually done using KeyShot displacement maps, where we were able to use them not only to just change the surface look of the material like a bump map, but we were able to actually change the model geometry. And so the speaker grills are actually a really good example of this. When we imported this, it was just a flat face, but we were able to use Photoshop maps to then have KeyShot insert those holes. And so we use the displacement maps on the wood and on the fabric to just help make them a little bit more realistic. And while KeyShot is incredibly powerful at doing this, prototyping a product like this is a lot more challenging and time consuming. Our prototype shop is incredible, but those lookalike models take time. And so often that means they become more of a showcase of a final design direction rather than using prototyping to help us iterate and make design decisions earlier on, which is actually why the speaker project was so cool. So KeyShot 10 was just released, I think a couple weeks ago, recently this month. And one of the new things that you can do is export your files in a new file type called 3MF. And the best part is that it keeps not just, the surface geometry like some of those other files, but it also keeps all of the color and material information of your part. And so what that meant for us was we were actually able to go from KeyShot, from a rendering like that one, and export our file into a format that is directly compatible with GrabCAD print. And so from there, we were able to utilize the capabilities of our Stratasys J55 printer and actually print out these speakers with realistic material exploration and really spot on color pairing. And so this is a photo of that rendering made into a 3D print, and we were able to kind of print them into parts so we could even slide and interact with the product like it would be produced. And I just love looking at the surface details on this thing. It blows me away, especially the fabric. You can kind of see that woven texture that was incorporated in from using that KeyShot displacement, and then being able to see that in a print is really, really cool. And of course, we didn't just use that to showcase the final direction. Because this process was made a lot easier for us, we were able to kind of print and make design decisions with models in hand way earlier than we usually do. And so we could have design critiques, not just of the various renders of the speakers that I showed, but also pair them with the printed version and see how everything felt and compared to one another. And another really important aspect of this design, of course, was just the hand feel and how it fit. And so we were able to explore the proportions, and being able to print these different models allowed us to validate if the sizing we picked was correct. And ultimately, this just brought us so much opportunity to experience and interact with the realism of the design. And so we were able to narrow down on textures and finishes that weren't the right way to go much quicker, because even though they seemed really exciting and engaging in a rendering, in real life, they didn't communicate quite as well. And so we were able to see that and make those decisions way earlier in the process. And of course, yeah, they just really helped us make decisions internally, and being able to understand how these were printing out, we could do some more 2D exploration to best incorporate those ideas and the decisions we could make based on the models that we printed. And so, of course, Stratasys was our client for this project, and it was completed solely during COVID. And so we weren't able to share these models during the process itself, but it's really awesome to actually think about how having a quick and realistic looking model like this is leaps and bounds further in helping clients make those really great design decisions and feeling incorporated into the process than even a really great in-context rendering. And so it's really cool to kind of think of what this could mean for future projects and future clients, of being able to interact with products so much earlier in the process. And so, yeah, it's just really cool to think about, in a couple of years, we might not be just reviewing sketches with clients, but reviewing multiple prototype models with completely realistic interactions in a way that actually doesn't completely ruin your project budget. That's really awesome. And all this to say too, as someone who still has plenty to learn and I'm always growing myself, this was relatively simple to understand and actually be able to take something from KeyShot and have it printed and see that process, which is really awesome when I think about the impact it could have on students and future designers too. There's so many different things that you can create. And when I think about how creative the GrabCAD community is, I'm really excited to see where stuff like this can go, and how KeyShot can be integrated more into models and the things that we see. And so with all of that said, thinking about how design realism can be used in the design process and some of these new technologies being released, what will you create? So that's all I have for you guys. Thanks.
Thank you so much for that presentation. As a designer myself, when you showed that sketch of the speaker and that I have the more of the detail, will just give the modeler to be able to create something beautiful out of that. It shows that even if it's just color, you can do so much when it comes to design realism. And that's something that strikes me as that I create models just for fun and stuff like that, and stuff I did when I go for video game design. But when we had our artists create sketches of a certain level that they wanted to create, we needed more detail. Something would just say, they give me a box here and all this other stuff. I was like, I need more. I need you to put your idea on the table. So yes, just seeing that sketch and be able to create that whole entire model was just really cool. So I thought it was awesome. So yeah, Anthony, do you, first actually, before I say that, anybody who's currently watching the live stream at the moment, if you have any questions for Alicia, please definitely write that in the chat right now, and we'll definitely get that right to you, and we'll definitely ask that question to Alicia. But I know Anthony definitely has some burning questions right away, so let's see what you got, Anthony.
Yeah, I really, really enjoyed your presentation. It was very, very thorough, and I was blown away, like, once again, with the design realism, and once again, like, the devil's in the details, and then just getting into, I guess, the minutia of it, just getting like that getting that feel, getting that right coloration, going from like shore values, just making sure everything, it makes a world of a difference. And that's something that I am, like, sort of a designer. I know, like, bits and pieces. Like, I know a little bit about Rhino, a little bit about SolidWorks, and then a little bit of Blender. But KeyShot, I've had very limited experience with it, but it seems like a very intuitive type of software. So I was wondering, like, what would be like your go-to CAD software, rendering software, when it comes to creating these realistic parts and designs?
Yeah, for sure. I think in school, we actually learned a lot of Fusion 360, which is, I know, usually not a very typical answer, but at PD, we'll use everything from SolidWorks. I think a couple of our engineers will use Creo sometimes, and then, again, mostly using KeyShot. And while KeyShot can be intuitive, I think there's a lot of really great preloaded materials that they have, and a lot of support for just kind of throwing some materials on there and getting really close really quickly. A lot of those details do take a lot of time, and I'm not to this level, but there are some designers that you will look at who will go through the process of adding dust and scratches to renderings to make them that realistic, and it's incredible. There are so many renderings out there that you cannot tell that they're not photographs. And so I think, it's kind of that 80-20 rule. You can get 80% of the way, but that 20% that really sets it apart there is a lot of figuring it out and a lot of exploring different nuances within the software. But I mean, we live in a really awesome time where there are access to that, a bunch of that information just on YouTube and different tutorials like LinkedIn or Lynda, where people kind of go into those. And so I've always used KeyShot. But yeah, there's definitely always more to be learned in kind of all of those softwares. But
Nice.
Awesome. So I think we got one question in the chats just now. Can you talk a bit more about what kind of techniques you can use to make a render realistic? How are you able to add more of these lighting details like in the lacrosse example?
yeah, so I think something that we can pull from a lot in rendering is looking at product photography. And so a lot of our designers who are really incredible at creating compelling renderings are also really compelling photographers. Because we make products, we do have to photograph them a lot. And so understanding what makes a compelling photograph actually helps you transfer that into those renderings. And so sometimes what you can do is using, Google or Pinterest to look up really great examples of where the lighting is really compelling, or where you think the contrast and the way that the rendering itself is oriented is really interesting, and then mimicking that. I think so much of design is doing master copies and practicing and finding the way someone has done it, and then trying to reverse engineer it and do it yourself. Of course, that is not a push to plagiarize at all. Don't claim it as your own, but seeing great renderings and being able to kind of recreate them is definitely one way. I think the other is kind of doing the balance of seeing a product in real life and then trying to render it. And I think GrabCAD actually would probably be a really great way to do this. Is like, for example, if you want to render a computer mouse, you can go on GrabCAD and get a computer mouse and look at yours and try and mimic the materials, try and mimic, is this really reflective? Does it have a texture to it? Is there texture underneath of a coating? Is it soft? How does it look and feel as you kind of move it around? And using that balance of something that you have in real life and then trying to just nudge and change some of those settings to help replicate it.
Awesome. I think we just got another question saying, asking, can you use Photoshop to render?
Yeah, definitely. I think some design consultancies don't necessarily use Photoshop renderings as much as Priority does. It is actually still a really big part of our design process, which was really amazing for me coming in as an intern, because that's what you learn in school, is how to you go from marker renderings to Photoshop renderings. And it is really important to be able to still communicate those in a way to draw. Because if you're not doing the modeling, you need to be able to communicate to the person who is what that design intent is, and also communicate to fellow designers. Speaking concepts and ideas can only go so far. And so when you have renderings that are pushed to a higher level, you can better critique those renderings and better have an idea of what will make the best product. Because sometimes, in a loose sketch, you might not be thinking about how tight a radius is or the actual surface finish of a part, when those can really make or break a design. And so you can definitely use Photoshop for rendering. That is what we primarily use. And it's definitely a process, but again, lots of tutorials, lots of using paintbrushes and layers and adjusting things like that. But yeah.
Awesome. Anthony, any other questions you got?
Yeah, I do. I was a bit curious, since you mentioned that Priority Designs has like a dedicated, shop. Do you have like a preference of printers when it comes to like achieving that hyper realistic like design part?
Oh, I will say, I think part of that comes from me not having worked on a bunch of projects that have gone through the prototyping lab. And I think it just depends. It depends on what you're really going for. I was really blown away by the J55 and just the fact that you can throw one file on there and print something with multiple different colors and parts. But I also had another designer just show me the other day a part that was kind of using the same technique of going from KeyShot to print and some of the detail that was incorporated into that, which I'm not sure which one that was printed on, but it was just really cool to kind of see a lot of it is in that intent, and then being able to have a printer that doesn't hinder your intent, I think is the really important thing. A lot of printers can do a lot, but making sure that it can get across what you are trying to is probably the most important part.
Good answer. All right.
Okay, I think we have time for one more question. So I have one question. So when it comes to rendering, and someone who has no knowledge when it comes to rendering, what is the best advice that you should give to, like, maybe a college student when they're just trying to get into like product design and rendering?
Yeah.
I'm sorry to put that kind of question out there.
Yeah, there's just so many things.
Right.
I think the biggest thing is just getting in and trying it. Reaching out to other designers and asking is actually would be a big recommendation, I would say, just because if they can share with you the way that they do it, there's so much more knowledge that happens. I know when I was first learning how to Photoshop render, we had a class where we had someone who sat in front of the lecture hall and we just watch him render things, which was really great, except for the fact that he used a bunch of hotkeys. So we had no idea what he was doing, and just stuff was happening. And so it was really interesting to watch. But there's this balance of kind of participating at the same time and kind of messing with those things yourself. And so I would say definitely just jumping into it. I think that's kind of a cliche. It's just doing it is kind of the first step. But I really think, it's the same way when you kind of learn to draw, or if you're learning to draw faces for the first time, you're going to look at a photograph of an eye, and then you're going to draw an eye, or you're going to look at your eye in person and do the same thing. And I think there's that whole process in Photoshop rendering as well, is learning how to use that tool in the same way that you use a pencil, or in the same way that you would use paints, to communicate what you're trying to, and starting to get a grasp on what it can do so that you can better use it. And so I think a lot of it is just trying, and it doesn't always have to be rendering products. You can just, use the software to kind of explore and see what it can do, and then allow that to kind of help build your foundation to then start taking things that are real and transferring them to make them digital.
Cool. Fantastic answer. I hope a lot of our our people who are currently watching will take that advice, especially our new college students and people who are new into product design and rendering. So yeah, so Alicia, thank you so much for speaking to us today, and a great presentation. It was fantastic.
Awesome. Thank you so much for having me.
Thank you. All right, so Anthony, who are we going on to next? We have to reintroduce our next speaker.
Speaking of getting into, I guess, that added manufacturing, design, realism, rendering, and like design, we have a professor who is an expert at those things and is well versed at teaching a wide range of students, whether you be a beginner or a master. So I'm happy to introduce Bernard Guy, professor from the Victoria University of Wellington in New Zealand.
Okay, just make sure I'm unmuted, Anthony. I will kick off this presentation. Let's get going and see how we get on. Make sure we can get this going right. Okay, Anthony, is that up? Is that up? Can you see that?
Yep, I can see it just fine.
Great. Okay. Hey, Alicia, thank you so much. That was, I'm feeling a little bit meek now after that presentation. It's like, wow, far out. Great work. Great work. So what I'm going to do, guys, is probably come at this in a little bit of a different way in some ways. I think Alicia has provided just a wonderful spectrum of an industry, really. And what I want to talk a little bit about is education and using these technologies and how we, I suppose, grow or inspire young students in a university environment. So what I've called my presentation today is Physical Futures. And when Anthony invited me to do this talk, and I was going, design realism, what's that? And I was sort of cracking up thinking, ooh, what is that? And the more I think of it, in some ways within a university or an educational thing, and I'm thinking about it going, yes, there is design realism in the work that you're trying to actually make. However, sometimes I feel like design realism is a little bit about a student trying to find their identity or trying to find where they want to go, the language that they're going to speak through design. I teach a lot of students that come into the university and they're not strong with writing skills. Sometimes they don't speak particularly clearly or something like that. But their love of the physical or the creative is really, really powerful. And a lot of it is the realism for me is to actually say, where do you fit in the design community? So what I'm going to cover today, guys, is, it's quite a lot of an education focus, really. I've been working with Stratasys, with the polyjet printers for a long time, really. We have a J750 on campus, which is similar to a J8, which is a full colour, hard and soft polyjet printer. And I've also done some work on the digital anatomy printer out of Shanghai. So what I'm going to cover is I'm going to cover some 3D printing right in the first year of university. So this is students who come in and they're probably 18 years old. They've finished their secondary school. They maybe have been out for a while. And when I teach at that level, how I introduce polyjet printing, GrabCAD, etc. Then I'm going to go on and talk a little bit about how we use 3D printing with the Stratasys machine and GrabCAD in outreach. So how we take these technologies out into the community a little bit. And it's not so much for a student, it's more of an activity. Then I want to go into a little bit of postgraduate research. So this is for students who have completed a 3-year undergraduate degree. And they're going to go on and do a master's and spend a couple of years on a particular project. So I've got a couple of projects there that have just been recently done that I'll talk about. And part of that postgraduate stuff is I want to talk a little bit about the notion of GrabCAD with parts and assemblies, and that's how we normally make things to be printed versus the voxel and the bitmap method, which is quite a recent method that's come up, and it's sort of an image-based method. So I'll try and go through that and explain that. So let's start. Okay, this idea of coming into university and you think that you might be interested in design and you end up doing a design course. And I run one which is really focused around inspiring students to make. And they come in and often they go, oh, we don't want to make more stuff. Because I think they're also really, there is a thing where they don't want to make more objects, more useless objects. So we do have a bit of a generation coming through who are thinking about sustainability, thinking about materials, thinking about the products of the future. So trying to find projects for these students which will actually allow them to be creative, allow them to learn, but in somehow be useful, or they can impart work into them. So we do quite a range of little projects, and I try and give them a little product focus. So this one here is we make a little pendant project on the polyjet, and I'll just run through how I actually teach this course to students when they are first starting out. Our students come in with pretty much no CAD knowledge at all. And so we really do start from scratch. And I might have students in my class which are doing biology or classics and stuff like this. So they do tend to come in from all over the show. So what I do is, what I've found is that I make tutorials. So I record them on screencast and I put them up online. And so what we have here is just a snapshot of the tutorials I put up. I'll put a link there. So if you can download this later on. You could actually go there and watch one of these tutorials. What I've found in the past is that I would try and write these things, in a list of like a workflow. And that was a real struggle. And pointing students towards YouTube videos, it doesn't give you the depth and the connection with the students, with the technologies. So what I've found now is I actually sit down and I write bespoke video tutorials where I actually do the projects. And I sort of show a little bit how naive I can even be with CAD. So I go through the whole thing, upload it, and then they watch it. And I've found this super successful in the last couple of years, that I'll see students in class watching the videos, rewatching them, rewatching them. They'll be watching them at home, and I'll look at the hit rates on them, and they'll be huge. So they can pause them, they can stop them and see all the steps. Because the thing with you're learning these CAD programs, and I think even with Alicia talked a little bit about KeyShot, you've got to just make sure you go, oh, yeah, what was that? What's that sort of stroke there, or what's that point there? And if you can wind backwards and forwards, you can learn in your own time. So that's one of my methods that I think is really super successful. Once students go through that, we think about some of the projects that we might give them, and I try to give them at least maybe one or two projects that have almost like a product focus. So that often in the past of teaching at a university in first year, they end up with quite a few conceptual projects where they sort of end up with something strange, that's spatial and stuff, and it's lovely and it's all educational, etc. But they're sort of sitting there going, man, I want it to be a designer, I want to make something. And so I've come up with a few projects for them, which they actually get to make a product. They'll print it out and they take it home and they can share that, I suppose, that education with their parents or their grandparents. So one of the projects I do is a button. And it's quite lovely. They design it. We use Fusion, or sometimes we use Rhino, and they'll design it very simple design. They'll follow tutorials, take it into GrabCAD, and pretty much color it in. And what a wonderful introduction to design is that it can be this simple. So I think GrabCAD works really, really well in this format. And here's just an illustration on screen, really. This is the GrabCAD interface. And this is my button that I've drawn up. And here's all the parts. And I can go over into the color pickers, put my colors into it, select the areas that I want, and continue to work through it. And that way they can play around and explore. And these are very small objects, so they can print out a range of them and actually do iterations of it and find out what different colors look like, the translucencies, etc. One of the really important things, I think, and this is coming back to if students are going on to study industrial design, is that there's ramifications of when you design, how much material you use, the cost of what you're making, and these sorts of things. Maybe this is almost like a design realism in some ways. It's a checkpoint for them. And so what I really like to do with the students is when they're making an object, they go down, they use a little estimate button, which is in GrabCAD Print, which is really good. And they go up and they find out how much material is actually in their work. So they have to go back and do this little calculation. They just don't get to have a free-for-all where they can just, hey, I don't care how big it is or whatever. So I get them to do the little calculations of saying, okay, I've got my button, how much material goes into it, so how much support material goes into it, how long does it take to print, which is really nice, and they get to understand things about scale and cost. And then what I've also designed is I've designed a calculator for them. And so these are all things that come with almost like a package in a course. Your tutorials, GrabCAD, the calculator, and they go through and they put in how much material was in my estimate, what was the print time, and then they press the button, and at the end they get a cost, which is really nice in the fact that they suddenly go, oh, okay, I wonder if I could bring that cost down a little bit. Can I change that cost? Oh, I can print 2 for the same amount. The J750 has a tendency that the higher you print, the more it costs. So if you can spread your work out a little bit flatter, you can get more for less. So this is a screenshot of first year student work. And in this one here, this was a pendant. So my project that I designed for them here was to say, okay, we're going to make a pendant. You can come up with an idea from wherever, from I suppose precedents that you might find, or you can go back to your family, or you can think about the sorts of things that you like. And the one really lovely thing with using this process is that you get this, I suppose, again, the realism is that you're exploring a really new technology. You're exploring full color. You can put all your desires into an object and there's nothing really missing. Sometimes when you have a design project, you sort of say, well, you can do this, but it only comes out in black and white. Here's your ability to print in full color. There is no excuse. There's nowhere to hide. So it's actually a really lovely technology. And it has that limitation of saying, we don't want you to make large objects. You need to make small objects. You need to concentrate on the detail. You need to explore how you impart as much as possible into a given area. So the students would design their objects, upload them into GrabCAD, align all the colours, put all the colours in, export them out, and our technician will print them out. And here they are on the printer. And then they'll put them through the bath and they'll wash them, remove the support material. And on the right-hand side, that's some of the work that comes out. And you can see there how eclectic it is. And there's all sorts of different imagery going on there. And one of the other things I really love about this technology is that students the work is very different. We have this really broad spectrum of ideas come through, which in past projects, sometimes the projects become a little bit stereotyped or everyone's starting to make things that are a little similar. Where here, I look at the students' work and I go, my God, I couldn't come up with this stuff. One of the other things we do with these projects that we're running in first year when we first get going is that I get the students to put their work and post their work up on Flickr. So I have a Flickr site. I have about 120 students in my class for this project. These projects go for about 3 weeks. And what we do is we put all the work up on Flickr. And everyone has access to this. So all of the students can see it. And I find this is another really good teaching method and learning method where students can learn off their peers. So they'll be seeing each other's work live. And the students take a real pride in how they present their work. So that thing of photography is really important. And I really express on them and say, look, it's very important how you capture your work. So if we're doing soft agilis work, you're making videos of it. If you're doing rigid work, you're maybe trying to get a context, or you're putting up some of your KeyShot renders and things, and really trying to tell that story in the best way possible. Thinking about this almost as your portfolio page. But it's very cool. So in the end of a class, we'll have a Flickr site with probably about 1,500 images on it. And again, students can go home, back to their parents, show their parents and say, this is what we did at university in the design school. And it's an open portal. It's an open forum. And I really like that. A lot of courses don't seem to have that. It gets a little bit hidden. So this is really nice. So some of our projects. So what I'll go through now is some of the results of really young students given, I suppose, basically the atomic reactor when they've come into university and we've said, go and use the coolest piece of equipment in the university. And we'll let you do it. And they go off and make amazing objects. So these are earrings. This guy here, he's made himself some sort of pendant and he's put his little colours into it. He's taken those little chips out of it. It's like a shark's tooth. And again, I want to see students taking things like a context photograph. I need to know this is the product. if you're coming into design, you're making an object for someone. Communicate that. You cannot just photograph it on the bottom of your table, the lonely object. You need to sell it. You need to impart that meaning into it. You've got it that far. So what happens with the prints is that the students will get the prints back off the machine, and then they'll take them away and they'll sand them and polish them, put the details onto it, maybe the earring clasp, etc., and take them that next step where they do become products and they do become part of them. And they're very proud of these pieces of work. I get them to write a little piece of text about it. Again, thinking about that future portfolio for when they leave the university and they might be heading off to get a job, trying to say you need to be able to explain your work. So these are just some examples of some of the students' work and how they capture that sort of what they're up to. This is a really nice piece here, and it sort of shows the capability of what you can actually get out of the PolyJet machine. And this is simple parts, and the student's done this little project where it's just waves, inside some clear with a little bit of green on it. There's numerous parts in there, but they've really, I suppose, explored the machine in quite a deep way. And I think that's what I'm after. I'm saying we've got this piece of technology at the university. We don't just want to make bricks with it. That's not going to do it for us. What we want to do potentially is to say, how do we make product with this? So again, some more examples of the sorts of different qualities that you can get out of the PolyJet. And this is all done here with just with rigid materials. This is a really lovely piece of work so, one of the students did. And again, very simple. So you could imagine that's basically a square that you drew in CAD, and then you drew a whole lot of little lines there, maybe on a vector program, but you drew some lines, extrude them through it, so it turns it into numerous parts, take it into GrabCAD and colour it in. So what's lovely is that we've got a technology which is going, feels like it should be an industrial design and three-dimensional objects, but which is translatable in some ways to communications in the graphics industry or into the fashion industry. And I'll show you some examples of that in a minute. And here's this piece of work. Really stunning. And here's one here where a student, you can actually see that idea of using it as a graphical piece. And these are small little bricks, so these are probably about an inch by maybe a couple of inches high, something like that. I did that translation for you guys then. But the thing of putting text into it, putting colours, translucencies, and using the full gamut of the materials in GrabCAD. And that's one of the things where you're making those tutorial videos, you can really demonstrate to the students how you can use those different palettes, the Pantone palette, the Vivid palette, the color picker, the translucency, etc. There's a lot there, and it goes quite deep. GrabCAD does look like quite a simple program, but by the time you really dig around in it, you can do a lot. Yeah, thinking about even the fashion industry. So one of the other projects I do with them is the buttons. And so the students get to think about part of their clothing. And I say, well, make some buttons. And you might make them for someone in your family, or you might make them for yourself. And then they go off and they find a precedent, etc. And this is a really nice example of a student that made some for her, I think, for her grandfather. And I said, when you photograph them, you need to tell us that they're a button. So this is this whole thing of making a design come alive. It's not a stagnant object. It's something with a story to tell. And you can see that these are these lovely sort of tartan, I suppose, buttons, which would fit onto maybe some sort of jacket. And she spent a lot of time on it. The other thing that comes along with this project is that when students see this, they go, oh, man, I could make a business. And I go, ka-ching, exactly. The ability or the potential for these technologies for entrepreneurial startups, I think, is fantastic, especially for students when they're thinking about saying, yeah, I'd really like to do this. I think I could make it work. I could start a small business. I could do this bespoke stuff. I could work in the fashion industry and do these custom objects. Because you could imagine you could make buttons and every one of them is different. They could have images on them, they could have faces on them, they could be designed for particular shapes and forms, etc., etc. And the mind just suddenly opens up. And for young students, when you tell that story, they go, ka-ching, oh, wow, yeah, far out. There is a future. Some things are worth making. Okay, I'll move off from those first year projects, just where we're just getting them started and teaching them about things like GrabCAD, to where we go and do a bit of outreach. And when I say sort of outreach, I'm thinking about how we take a piece of technology and share it with the community, and how it's actually quite a nice, simple piece of technology to do that with. So this is a group of students that had travelled over from China, and they were touring New Zealand, and we have Weta Workshop, Weta Digital in Wellington here, so they quite often come and tour the movie studios and travel around. And they came to Victoria University, and I said that I'd actually put on a little workshop for them about making something on the Stratasys polyjet machine. So I said, well, I'll just take one of my projects that I've got, my pendant project, and pass that on to them, and they can come in, have a fun time, make something, and explore the design process. So what I did was I just drew up a really simple shape and gave it to them as a template. And so this is another thing where GrabCAD works quite well. In fact, is that you can actually make up a template, bring all your parts and bring your design in, and invite a group of pretty much naive users in, and they sort of can't fail. It's like colouring in. It's not a great choice of words, but so everyone came in and they chose a template. I had about 6 different templates, and they sat down in front of some computers and they just coloured these objects in and had a great time doing it. Buried themselves in the computer for probably 2 hours. And then once they'd finished doing that, we took them, printed them out downstairs on our machine, and the students came back the next morning and polished them up. And we've got little buffing machines here with some sandpaper and all sorts of different polishes. So here they all are inspecting their work and really getting into the detail of it. And then they're taking them and putting some little hasps on them and strapping them on, etc., etc. So as a piece of technology that you can use to, I suppose, engage with your community, it's pretty neat. You couldn't really do this in many other ways. What would happen is that the learning would be too great. The other one I do with the outreach is this is some staff. This is our administrative staff at the university, and I invited them all in and said, let's spend an hour making some stuff. And they were really engaged. And again, I just used templates, and they came in, put some different colours into them, came downstairs, printed them out, did a little bit of sanding with wet and dry, went off and polished them, and just absolutely loved this whole idea of being engaged in the design process. So if you've got a community that maybe is interested, this technology can work really well. And I think I'd really like to try this at a distance where we could actually engage with people in either in different countries or different part of the country, that they could do this online, and then we could print it and we could send it back out to them. There's their work. Moving on from that really, I suppose, that really early stage of learning with the polyjet printer, and you're just really making quite simple shapes and forms and learning how the whole system works. This is a project that I do in the second year. So these are students that have been there for a couple of years, and I do a course which is called Design Physiology, which is really a sort of, I suppose ergonomics might be a comparative term. But what I like to do in this course is I give them a project where they use the PolyJet printer to make a product for themselves, and it's all about tolerance and it's all about fit. And it's one of the things that's so important with design is that how does an object or a product fit to the body? What's the sensitivity? Does it just touch? Is it tight? Is it loose? What part of the body is it fitting? How does that fit? How does it hold on? Does it slip? Does it slide? What's the texture? How have you designed it to hold on to the body? So we do a series of rings that the students fit onto their fingers, and we run these all through our machine. And we use both the rigid materials, which are the Vero palette, to print rings. So it's quite a hard object. And we also start to explore the soft palette of the machine, which is the Agilis palette. So on the left-hand side, what you'll see a student, they've designed a ring, and the bottom part of it is actually really, really soft. So it's sort of it's quite malleable and bends up and stretches and moves around. It's quite a fascinating one. On the right-hand side, a series of balls, rigid and hard. And the one in the middle is actually a little bit of a detractor, because that's one which we do in metal. We actually send it off to Shapeways and they print it in metal. So that's the students' project in second year, where they design a piece of jewellery for themselves, but they do 3 of them, which is really, really quite nice. All about that thing of the perfect fit and finding out where that tolerance is to the body. So it's really nice, sort of a piece of personal prototyping. Pretty exciting projects for students coming into the university. And again, there's that sort of idea of designing a product behind it, something that it's not just a spatial exploration. So this is some examples of a student's ring project. So some of the capabilities that you can get out of the PolyJet printer. Beautiful pieces of work. I added this strange piece of work into the presentation as well, because I thought it was a little bit older, and it was before we had the J750. We had a Connex machine. Before that, we even had an Eden machine, which was just a mono material. But it was a PolyJet material. But the reason I added this was that one of the things that is super cool about these machines is the notion that you can build parts within parts within parts within parts. And I used to run a project where we used to explore the anatomy of the body and recreate that anatomy as a 3D printed object. And this was a student that did a finger joint. And what you can see here is there's a sphere, and then there's another sphere inside that, and then there's yet another sphere inside that. And so this idea of this engineered mechanism being able to be printed all as one is quite fantastic for students to be able to actually engage with. And it's very much links back to the way that the human body actually is. You can only grow that shape. You cannot tool it and then somehow force it together. Continuing on, the projects start to develop and get a little bit more complex. This is a project called Lenticulate, which one of the students has done. And I'll just see if we can just press this, whether this will actually work. And you'll be able to see how we can use the qualities of the PolyJet, the translucency and the colour, to generate quite wonderful effects. So this is where you're sort of taking your design learning in first year, you're building it, and now you're getting into a little bit of design research where there's a bit more exploration in it, there's a bit more iteration in it, the depth of design in it is greater. Very cool. And when you're thinking about that as a product, you go, oh, okay, there is a lot of potential in there to be able to make a product. Now, I'll just see if I can get to my next slide. And this is another one. This is a couple of years old now. And this one does a similar thing, but it's done in a very soft material. So this one here, Nicole Hone explores the qualities of the material in the Agilis as being characters. And she made a range of characters, and she was quite focused on the movie industry here of saying, well, you've got CGI. Can you not actually make these objects that you could use in the movie industry? But they're physical objects that you could interact with, and we'll print them out on the polyjet printers. What we do quite a lot of at the university is we focus on the flexible nature of the Agilis and how you can inflate it, or using hydraulics or using air. And so you're sort of designing it in its crimped up form, and then you're pumping air into them. So you're making active products. They're not stagnant, they're not static, they become dynamic. And that sort of leads us on to the next part of this, is where this idea of dynamics and detail come into place, where we are dealing with a piece of technology that we can make product with, but it has quite a close resemblance to how we're actually made. This is a little bit of research that I thought I'd just drop into it to, I suppose, to demonstrate how I take this technology out of the university and share it with quite a few of the medical clinicians. Here in Wellington, I do a lot of projects with the local hospital. Very short projects often, just demonstration projects. But this one here is we did a pediatric trachea. So this is a trachea breathing, basically running down into your lungs of a baby, so a newborn. So we got the CT scans, took the scans, and then developed a trachea and then printed it out. And this was so they could actually intubate it and learn how to intubate a newborn. So that's when they're putting an endoscope down into the lungs to check for damage or blockage. So that's sort of one of the sorts of projects that we engage with. And this project now has grown. It's pretty complex. It's become a bit of an IP nightmare. So we can move on to that one. But staying with this world of, I suppose, people and the medical community, I've got another project where we'll start to talk a little bit more about the details of how we work on the J750. So this is, we're going to go into move from parts and assemblies and simple objects to this idea of the voxel. And many of you would have heard about the voxel. Some of you may understand completely about what the voxel is, but I thought I would just go through it so we can actually start to understand that it is quite a different way of 3D printing. Okay. So this is a little quick snippet here of what the voxel actually is. So if we think of our screen as being made up of a whole lot of pixels, yep, little tiny little squares, and they're 2D and they're pixels. They don't have a depth to them, they just emit light. If we were to take those pixels out and extrude each pixel so it was three-dimensional, we'd have a voxel. And that's pretty much what it is. You just stretch it out. So if any of you have ever been on Minecraft, pretty much Minecraft is voxels. So we take a 2D pixel, we stretch it out, it becomes a voxel, and then we stack the voxels up. So they become, like here on the right-hand side, building blocks, which can then be printed. So out of a layers and layers, which we call a stack, we end up with a three-dimensional object. Each one of those layers has color data, has pixels in it, and when they come together, they make a three-dimensional object. It's a very different way of printing. But how it works wonderfully well is it works well with biomedical imaging data. So if you've ever had a CT scan or an MRI scan, what you'll get back is you'll get back a file with a whole lot of images in it. And it's a stack. And you can run through it and see through your body. Boom, 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 boom. You're sliced up, basically. It's very similar to how a printer works. Printer slices the data, prints it out in layers. So there's a direct correlation. Okay, what we did here was we did a really interesting project where we got the visible woman. There was a data set of someone who had passed away and they'd been all sliced up, and we took the image stack from that and pretty much as visual images and 3D printed it. So we ended up with a person inside that. But it's not done with parts, it's not done with mesh-based STL files or anything like that. It's actually done with the voxel process. And what that allows is that you can have this really phenomenal level of detail. Whereas if you look at this image in the middle here and you're going down through the spine, to try and make that as STL files so you'd have all these separate little files, your file size would be bigger than the world. It would be huge. And the level of detail and I suppose how one colour flows into another, you would never really get. And you could saw this in half and you'll have that data all the way through it. So we're actually talking about an object or potentially having product where the aesthetic is more than skin deep. You can have an object which you can just cut up or carve and open up, and it's entire all the way through it. So these are just some examples of the sorts of qualities that you can get out of work when you're actually voxel printing or printing from these images. Coming right through here, the cross section. So we do quite a lot of this at the school and help, I suppose, the local medical community start to understand a lot about 3D printing and when is a good time to print and when is not such a great time to print. And this is a really interesting one here. I work with a neurosurgeon, and this is a circle of Willis, and this is a aneurysm, which is when you get a little inflation in one of your blood vessels in your brain, and it can be really life-threatening. It's quite problematic. And we printed these examples out for him, and it was really useful for him to communicate to people who came into the hospital about what is actually going on within their heads. So when is this aneurysm getting quite large, et cetera, and what they're going to actually do about getting rid of it. But this ability to actually get a really truthful representation of what there is. And it's quite a beautiful object. And I think somehow having a physical object is really useful for people to actually understand what's going on inside their body. The body's one of those things that's not transparent. You can't see into it. This is another one here of looking at using the flexible materials, and I'll talk a little bit about this later with one of the last projects that I'm going to show. Again, putting the CT data and then putting it into flexible materials. So we're getting closer to mimicking the human body. Why would we do this? Well, I think there's quite a range of reasons why you might do this in the medical community. You might use it for simulation. You might use it for training purposes. One of the things that I'm really fascinated about is this notion of consent, that when you have an operation, you need to consent to it. You need to say, yes, chop my hand off or whatever you're going to do. But having a physical model could be quite an important part of that system if you were going to say, yes, you're going to do an operation, there is a risk. I'd actually quite like to see it in a model form. Yep, now I can understand about what you might miss or what you might cut. And the other one was that I thought consent might be quite useful, or this notion of a model in a community where you've got your family group or your extended family. Maybe it's English second language and communication is quite difficult. By having these very detailed medical models, the understanding and the risks of what can happen during surgical operations could be more clearly understood, and therefore the consent process is maybe a little bit more valid. Okay, this is another project that a student's just completed for her master's, which is really, really fascinating. And when I said here, in some ways, one of the things about these technologies is that we have a really interesting gender balance in our classes. We have a very 50-50, young women, young guys. both are very much attracted to these sorts of technologies of using them. And so we in the past, industrial design used to have quite a lot of young guys would come to it wanting to go to the workshop and make models, saw stuff up. Now that we are more and more digital, that's turned around, and we have a large percentage of smart young women coming in wanting to be industrial designers and use this technology. This is a project all about trying to communicate data, now big data. And one of the areas we saw when we were thinking about this idea of physical futures, what are we going to make? What are we going to keep making with these technologies? One of the things that was interesting was say, how do we communicate really big data at the moment? How are scientists trying to talk to us? And one of the ways that I suppose they'd like to talk to us, I think, is through physical objects. So rather than saying, here's a graph or here's a Venn diagram or something like that of what's going to happen, or here's just a whole lot of metadata, you guys figure it out. Our hypothesis, I suppose, was to say visual objects or the physical object could be a lovely way of communicating this big data. So one of the students used the voxel technique. And I go through it here. She used Grasshopper, Houdini, which really does come from the movie industry. So you can see we're actually borrowing a lot of programs now. This is getting pretty complex. And then finally going into GrabCAD to actually print out a series of shells, which she just dreamt up, and she called it future fossils, about what they might look like. So this is really making objects that you can't really make as a part. They have to be sort of, I suppose, whispered on, or you've got little tendrils poking out of them and drifting out. You've got to grow them. We're growing a product in some ways. We're putting data in and growing that graph or growing that communication. So what she did, this is her starting process really, was that she did a lot of experiments around on the machine. And that's one of the benefits of having a machine like this in your basement downstairs, so that you can actually go down to it, put on a run, go back down the next morning, take the work off, test it, evaluate it. And so this is the sort of thing most of our master's students will go through, a huge amount of iteration to try and figure out what they're actually, I suppose, a criteria for where they're going, trying to figure out how to put colour into things. Will it work with Agilis? Is it still soft? Is it rigid? And this is using the Houdini program to grow surfaces over the top of it. So she's talking about our shell form and things being blown around. I think she was looking at things like the acidification of the ocean and how shells will change over time. They're actually going to lose their shells. So we're going to end up with a whole lot of little mollusks without shells. And then she wanted to represent these. And so this is the actual 3D print here. And so that's the file embedded inside, encapsulated, I suppose, inside the clear material, the Vero. And she ends up with this actually really beautiful story of future fossils, or the future of shells. And this means that you can imagine here, this is an exhibition. We just put this up as a bit of a mock exhibition, but the idea of communicating really big data or environmental futures and saying, hey, look, this is going to happen if we don't need to do this. And here's an example of it. And people can actually pick these objects up and inspect them and explore them and say, gee, okay, so they're going to all lose their shells, or this is what it's going to look like, et cetera, et cetera. And I think scientists are really searching for things like this to be able to say, wow, how can I almost make science beautiful? This is the final project I'll talk about, and I'll come back to the medical field. And I'll come back to the voxel and the process of making things with image stacks. So on the left-hand side here, what we have is we have a 3D print of a baby's foot. So we've just completed this project, and it's been a pretty amazing project, really. We've worked with quite a few people, including the Stratasys in Shanghai using a DAP printer, which was really lovely, and it was a neat collaboration, and hopefully that can continue. what we did was we wanted to explore, I suppose, the validity of two different methods of 3D printing. One was mesh-based modeling, and this is in the medical field, where someone takes a stack of CT scans and they make STL files out of them. And another process, which is what we call a bitmap process or a voxel process, where we read those image stacks and send them straight to GrabCAD. So what we did is we really looked at it and sort of said, the time that is spent, it's quite a labor-intensive process, this thing of making STL files, and the notion of automating this so we can pretty much press a button and convert an image stack into a print file. So what we've got here is you've got your 2D pixels, data stack, voxels, and there's going to be a little print there. And it works the same for the machine, for people. CT machine, and you get sliced up. That's your little slices there. Different pixels. You can do a printout here. So there's this little synergy between CT data and the PolyJet printer. And I don't think we've capitalized on it yet. And this is quite a beefy illustration here, actually, in some ways, but it is a workflow for how we could do that, how we could acquire data using already established technologies, how we can take that through a digital workflow into GrabCAD Print, press the button, and get a 3D printed model. And potentially this should be quite a big game changer. What happens when we do this, when we take these images in, what happens is you've got all these image stacks and you can do this half toning, diffusions, and so you can actually change things like the colors of the body. So you could bring things up for reference. So you could be saying, okay, I want blood vessels to be this particular color. I want to diffuse it. So I want to get a different depth or details and things. I want to highlight things. It's really, you're pushing into the graphical, into the communications industry. It's a really nice sort of bridge. Okay, some visual images of what we got. So the really big push for this project was to say we want to use the Agilis set of materials in the J750, which is the soft materials. We're going to do voxel printing, so bitmap printing from CT data. And potentially what we want to try and do is make a dynamic leg. So we can print rigid stuff now, but we wanted to say, can we get the biomechanical detail out of a body and then be able to move that body around? Because then we are truly emulating a human, which this printer is pretty much capable of, I think. So this is some details here. What we've done with these models here is we've actually stripped the skin off them. So this is the back of the knee, but we've stripped the skin off, and this is just the muscle tissue tendons. Again, the same thing here. And here's the little baby's leg. It's a bit scary, isn't it? And so we've stripped the skin off, muscles, what's in, and then when you do this, and then you bend this up. And there's the little toe. And so you can flex the toe back, and you can start to understand this is how the body actually works. And so for scientists or clinicians trying to understand this, this is fantastic. And I don't think we've done the rigid materials. Now it's time to move on to the dynamics of what the PolyJet is actually capable of doing. And these are some sorts of the details of what we did with the baby print. So the baby was pretty much a newborn. It was quite a complex ethical project of getting ethics for the scans, etc., and then slicing all the stuff up. But it was a really nice one because there is so little data around for pediatrics for newborn children. So this is a sort of level of detail that you can actually get out of the PolyJet printer. You're getting skin, which is almost like a layer that when it gets a little bit damp, it starts to pull away. It's like when you've been in a spa bath for too long and it's starting to stretch out. Your little bone details. You can actually see that when a baby is first born, that the bones aren't joined together. They're actually quite distant from each other and they slowly come together. And this is with the skin stripped off. So, yeah, rather gruesome sometimes, beautiful but gruesome. And this is really what's under the skin. So that's where I'm going to conclude my talk. This is a rigid print. I just put this in here because it was quite hard case. I was just polishing it the other day in the kitchen sink. Our kitchen sink seems to have seen quite a lot of polyjet polishing over the past week or two. So that's the baby leg with when we skinned it. Right, now I'm going to escape from that and stop sharing. Right.
Wow, that was a lot of information.
Yeah, wasn't it?
That was great. That was an amazing presentation there.
Pretty weird.
Anthony, any what'd you think?
No, I was gonna say, like,
you were gonna leave the room.
And considering I'm on my last year of school right now, you got me over here thinking, oh man, should have transferred over to your class.
I think the whole thing is to really try and make it fun. Try and make it fun, really engage and inspire that this is new technologies and this is sort of where it's at, you know? Get with it.
No, you hit all the marks in terms of, making it engaging and making it really, really fun. And I can probably imagine that a lot of your students, when they go into your class, regardless of their knowledge foundation, being able to work with you and then learn, and then being able to hold that part, what they designed in their hands, you probably see that a lot, maybe, right?
Yeah.
Like that impact.
Yeah, well, a lot of the young students are coming into the university and they are really wondering where they're going to go. There is the tradition of industrial design, but they're also, the more we use this machine, the more we're diversifying out into science, into medicine, into the movie industries. It's taking us into a whole lot of places industrial design's never really been in. And so it's just opening things up all the time. So for our students, they're coming in and they're going, where am I going to get a job? Where's my career? And they're looking at this as quite a future portal.
It is. Oh, I actually have a question from one of our viewers here. So, much like me, they got their mind blown by seeing all of this. So they're asking, is there anywhere that we can find more information for all of the work that you've showcased? I know you mentioned Flickr, but are there any other?
Oh yeah, I can. How do I put some links up? Can I write something in? Or how do you want me to do that? We've got some good websites that I could pass on to you.
Casey, do you have any good ideas? I think we can, if you send it over to me, and then we can just post it on Facebook.
Yeah, that'd be cool. Yeah, because I'll send over our research page. We've got a website for our research, and people can look at that. They'll be able to find stuff out. Most of the stuff is available, so yeah, I can give you quite a few links.
Awesome.
Perfect. Thank you.
Cool. I think we also got another question. It was an earlier question. Do you think this capability could create 3D screens in the future, just like pixels are used for 2D screens today?
Yep. Am I allowed to have one word? Yep.
Yep, one word.
Yeah. I yeah, definitely, and it's probably there's a couple of guys at the university doing research around that at the moment, which are trying to make three-dimensional screens. So, yeah, it's going to really change how we design products and how the computer tends to design products, or how we co-design products, I think.
Mm-hmm. Yes.
Yeah, that is really fascinating to see like the progression. And I guess when you were getting into like the complex like parts of it, because I saw Grasshopper, which is like, pretty sure that's a Rhino plugin.
Yeah.
So wondering. Oh, go ahead.
It does get complex very fast, and the students get into those programs like Grasshopper and then Houdini, and it's quite deep water.
Mm-hmm.
But in some ways, it's that realism is they're finding out where they're actually probably going to go. So those students are probably going to go into those sorts of fields.
I guess, how do you go about, I guess, potentially narrowing down, I guess, that really vast ocean of, oh, where should I take my design this way? I could take my career this way. How do you go about, I guess, like guiding a student or helping them like find like that niche that they want to fill?
I think that's where our industry partners come in place. So we'll work with people from the medical community, or maybe film, or from science. And it's having an industry partner, not so much controlling a project, but there as a mentor, as a sounding board. Not so that you're not designing the product for them so much, but they're there to say, yes, that could be useful for us, or that's a really interesting area for us. We're finding many of the companies in New Zealand that would never have had designers now have designers on board, just for that notion of having a creative team. So yeah, having someone from outside of the university just to come in and just have a little narrative is a really nice way of keeping a rudder on that boat. Yeah, otherwise the student, your projects just go out and it becomes complex really quick.
Right. No, that makes a lot of sense. Do you find that with like that open design element that sparks sort of like an entrepreneurship amongst a lot of your students?
Yeah. I think a lot of them do go off and start small business, or wish to start business in some things, I think we all want to do that one way or another. What we're thinking about at the moment is how we actually hub that. I think we need to support that system, and we haven't in the past. So we're trying to think about how we can support that as a university. So when students finish at the university, how we can, and they leave, how we can still produce work for them in some way, because we haven't done that. So I think that's something for the future, so that on support of entrepreneurial people for a couple of years once they've left the university, rather than just saying you've finished here and goodbye, you figure it out. What we've got in New Zealand is we've got a really interesting industry, because we've got some really big players like Fisher & Paykel Healthcare, and a lot of our traditional manufacturing has disappeared. So we've lost huge amounts of manufacture over the last 20 or 30 years because we import so much stuff. So we're almost reinventing this at the moment.
Yeah, it's sort of like an empowerment on multiple levels, because like you said, I guess creating this next generation of designers, you're raising the domestic manufacturing of where you are, but then, on those steps preceding it, you're creating, even if you're creating like product for like another customer or purpose or whatever, it still has like that designer's mark to it. So you're on multiple levels. It's a really empowering and inspiring thing that both of you are doing.
Yeah, it's pretty tricky.
Yes. let's see. Do we have any more questions? Let's see. I guess not. Anthony, you have anything else?
I do not. You've covered everything pretty well.
Yeah. I definitely gotta say one of my favorite renders that you showed in your presentation was the fingerprint. Yeah, I actually think like that's something like a really like nice sweet gift that you can give to someone, just like a nice gift of your fingerprint to someone. And like the things that these students created, it's just really cool that it's something that we wouldn't come up with, they can. And it's nice to see that different generations are always coming in with something new that you haven't seen before.
Yeah, I think that's where that machine really does blow me away sometimes. It gives them the ability to really play at a high level, but in quite a simple way. So their creativity is nice and clear. It's quite, it's quite beautiful, and you haven't changed it. I think it's quite easy for us as, I suppose, teachers to start to leave our mark on students' work. And with this machine, I think you can actually sort of step back from that and say, go for it. Let's see what you've got to offer.
Yeah. All right. Well, thank you, Bernard, and thank you, Alicia, for coming to this event and speaking to our community about the fields that you were working on and the future of design realism and all these amazing things. And yeah, it was fun. I learned a lot in this industry, and it's just it was just so cool to see these renders from both presentations. So, but yeah, Anthony, any words?
I was just going to agree with you, Case. Or first off, yeah, I would like to thank both of you for really coming out, participating, and giving it your all with these, with what you showed to the community and us. I also learned a ton of stuff and I just saw like a really wide field in which all this can be. I got surprised. I'm like, oh. Even though we work for a 3D printing company, it's like, oh nope, I'm still getting my mind blown every time.
Yeah.
So there is like a magic to it. So I'm very appreciative that that we're sort of ending the new year on a very hopeful note, that there's a next generation of designers, there's a new year to look forward to, and we can always learn something and grow and help each other with that.
All right. So I think that is going to be it for us tonight. Thank you everyone who came out and came to this GrabCAD online meetup. We should be having another one next year in 2021. Be sure to follow us on Facebook. Be sure to follow us on Twitter and all our social media accounts. And be sure to create your own profile on grabcad.com and join the community. Thank you to our speakers once again, and thank you, Anthony, for co-hosting, and our GrabCAD staff, Abe and Sylvia, for being our moderators in chat. Thank you so much for being here, and thank you, everyone. Hope to see you on the next one. Good night.
Cool. See you guys.
Thank you.